Hi guys, this is the second of the two videos on section 4.9, which if you just watched it, you should know is on antiderivatives. If you haven't watched the first one first, I would highly suggest doing it because you'll have no idea what's going on. Okay, so in this one we're going to talk about something called an initial value problem. So that's what this video talks about. It's just a certain type of an antiderivative problem. So we know we get a plus c when we take an integral or an antiderivative, which again means the same thing. So the goal is to figure out what that constant is. So how do we know? Wow, that's terrible handwriting. What the plus c is, and the answer is we can't if we only know the function we're taking the integral of, but if we're giving another piece of information, we can. And that's called an initial value problem, which is basically the integral that we're taking and then one more piece of information. Okay, so we're just going to do a couple examples about it, but this extra piece of information I want you guys to know is called an initial condition. And the best way to show you guys this is an example, so we'll just go ahead and dive right into that. So this is a word problem. I'll just write it out first. So we're going to let S of t represent the position of a runner and we're going to let V of t represent the velocity of the runner at time t, so that means instantaneous velocity, because if we're looking for the velocity at a single point in time, then it's instantaneous. If we were looking for the average velocity, it would be V of t representing the average velocity of the runner between time, say A and B. But we're just talking about one, so it's instantaneous. And if we remember, instantaneous velocity is just the derivative of the position. So what this is saying here is that S prime of t is equal to V of t. The derivative of the position is equal to the velocity. So if V of t is equal to 2t and the runner's position at time 0 is 1, what is the equation for S of t? So basically we want to find the position, the equation for the position of the runner based off of the equation for the velocity and the fact that at time 0 he's at position 1. You could say it's like a track and he's 1 meter from the starting line. I don't know. Anyway, so we're going to break this down into important pieces and then talk about what we know and how that'll help us find our answer. So we know that the derivative of S of t is velocity. We know that velocity is 2t, and that the position at time 0 is 1. So those are the pieces of information we know. So I'm just going to write those again down here. We know S prime of t is V of t. which is 2t, and we know the initial position. This is our initial condition. That the position at time t, or at time 0, is 1, which is saying the position s at time 0, so s of 0 is 1. And we want to find s of t. Okay, so what we need to do basically is undo this derivative, right? We have the derivative here. We want s of t without the derivative, so we're going to take the antiderivative of this function. So if we take s of t is going to be equal to the integral of s prime of t dt. We had dx before, now we're talking about functions with the variable t, so instead of writing dx, we just write dt. This is saying the integral of s prime of t with respect to t, which we know is just the integral of 2t with respect to t. And if we use our power rule that we talked about in the last video, we leave our 2, increase the power on our t. This is technically a t to the first power. So increase our power of t by 1, so we get 1 plus 1 over our new power, 1 plus 1. Eventually I'll stop writing this like plus thing up here, because hopefully you guys will then remember that I'm just adding 1. But for now, until we get used to it, I'm going to do that. And then we add our integration constant. So we know we have 2t squared over 2 plus c, which is just t squared plus c. And our goal is to deal with this plus c. And we're going to do that by using our additional piece of information up here, that s of 0 is equal to 1. So we have right now that s of t is equal to t squared plus some constant, c. Well, we know that s of 0 is equal to 1. But that means that if we plug 0 in for t into this function, that 0 squared plus c is equal to 1. Or sorry, rather that s of 0 is equal to 0 squared plus c, right? So that's just c. So in order for these two to be true at the same time, we have to have s of 0 is equal to 1 is equal to c. So c equals 1. And we have s of t is equal to t squared plus 1 for our final answer, because we just replace our c with this value 1 that we found using our initial condition, right? So our initial condition was s of 0 equals 1, and then we plugged in a 0 to the function that we found using the power rule, so finding the derivative or the antiderivative, and we used that to get rid of basically the t's, so we could solve for c by noticing that these two functions have to be equal to each other, right? Okay, so then this is our answer for the position function. We're going to do one more of these examples, just to kind of make sure everything's good to go. This one isn't going to be a story problem. It's going to be a little bit quicker. I just wanted to start with a story problem so it had more context. We're going to let f of x be the antiderivative of some capital F of x, which is going to be 3x squared plus 2x plus 1. And we're going to let little f, here I'll write my little f's a little curly this time so that you can tell the difference. We're going to let little f of 2 be 3. So let's rewrite what's happening here. So we say f of x is the antiderivative of f, capital F of x. So what that is saying is little f of x is equal to the integral of big F of x with respect to x. Okay? So first we're going to take that integral. Oh, sorry, I needed to actually write a question. Our goal is to find f of x, little f of x. So, what we know, like above, is that little f of x is equal to the integral of big F of x dx, and that little f of 2 is equal to 3. Okay, so we're going to first take the integral. So little f of x is equal to the integral of big F of x, which is the integral of 3x squared plus 2x plus 1 with respect to x. And using our power rule, we have 3x to the 2 plus 1 over our new power 2 plus 1 plus 2x to the 1 plus 1, because again, this is just x to the first power divided by 1 plus 1. And then if you guys remember from, I believe, the last video, this 1 is technically 1x to the 0. So when we take our antiderivative of that, we get 1x to the 0 plus 1 divided by 0 plus 1, and then our integration constant. So we're going to simplify this. We have 3x to the third over 3 plus 2x squared over 2 plus 1x over 1 plus c. And this simplifies really nicely to x cubed plus x squared plus x plus our constant c. Now, we can't leave our answer with this c because that's not a specific derivative. They gave us an additional piece of information. They told us that f of 2 is equal to 3, so we're going to use that to find this c. So we have little f of 2 is equal to 3, and from the integral we just took, we have that f of x is equal to, little f of x is equal to x cubed plus x squared plus x plus some constant c. So we have that f of 2 is equal to 2 cubed plus 2 squared plus 2. Also, I just realized I suddenly switched. Oh no, we're good. The last problem was with t. I confused myself. We're using x's. We're all good. Okay. So f of 2 is equal to 2 cubed plus 2 squared plus 2 plus c, because sorry, my brain just started a little bit, because we're just plugging in 2 for our x's, which simplifies to 8 plus 4 plus 2 plus c, which is 14 plus c. So we have that f of 2 is equal to 3, and it's also equal to 14 plus c. So now we can solve for c, and that gives us 3 minus 14 is equal to c. So negative 11 is equal to c. Okay, so then we just combine this guy up here, our original function for little f of x, and our newly found c, and we're going to have little f of x is equal to x cubed plus x squared plus x minus 11, because it's plus c, but c is negative, so it's minus 11, and that is our answer for this one. Okay, so that's how to use additional pieces of information. Again, those are called initial conditions, like this f of 2 is equal to 3. to find our values of C to get specific answers for our antiderivatives. All right, that is it for section 4.9. I'll see you guys tomorrow for section 5.1.